We often hear that there are three common architectures in multimodal AI: dual encoder, encoder, decoder, and unified generation. But here's a question that rarely gets a clear answer. Why do these models still struggle with mismatched understanding between modalities? Why do we still get image-to-text results where the description says one thing and the picture says another? For example, an image shows a dog leaping on the beach, but the model says the dog is sunbathing on a balcony. Or when we ask, "What tool is this?" the model replies with a generic scene description instead of answering the question directly. This isn't just about model structure, it's about what the AI is actually learning and whether different modalities are truly aligned in their objectives. Let's quickly walk through the three architectures. First, dual encoder. Each modality is encoded separately, then compared in a shared space based on similarity. It's fast, but the modalities barely interact. Second, encoder-decoder. Images go through the encoder and language is generated by the decoder. There's data flow between them, but the fusion is shallow. They don't really learn together. Third, unified generation. Images and text are both converted into token sequences, processed by a single model. But just because the tokens look the same doesn't mean the goals are shared. Each of these models focuses on input formatting, but not on aligning training objectives. Language training focuses on fluency. Vision focuses on detail compression. Motion focuses on temporal continuity. These are three very different optimization targets. If you force them into one model without aligning goals, you just get a puzzle of separate skills, not real reasoning across modalities. It gets worse. Language representations are abstract in general. Vision representations are concrete and detail dependent. If you force both into the same feature space, the model either loses fine visual details or sacrifices language generalization. Training gradients pull in opposite directions, and the whole model suffers. So the real problem isn't just the model architecture. It's misaligned objectives, incompatible representations, and conflicting gradients. Take Blip or Flamingo. They use encoder-decoder designs and seem to mix modalities well, but in reality, language dominates the process. There's no real two-way understanding. Clip-style models do a great job aligning modalities, but they can't reason across them. They were never trained to understand cause and effect between image and text. Even unified models like VAR-GT turn everything into token sequences, including images, text, and actions. But their training still focuses on generating within each modality, not aligning them at a reasoning level. In short, everyone says they're doing fusion, but no one agrees on what the modalities are actually optimizing together. Right now, training a multimodal model is like having a writer, a painter, and a physicist working at the same desk, each doing their own homework. It looks collaborative, but they're not solving the same problem. To make real progress, we need three changes. 1. Design a shared semantic space that works across modalities, so everything, image, text, motion, shares a common goal. 2. Introduce a unified objective planner that adjusts training weights dynamically and encourages cooperation between tasks. 3. Supervise the reasoning process itself, not just the outputs. For example, let vision trigger language, then predict actions, and guide that entire chain. That's what real joint multimodal learning should look like. In the next episode, we'll move from structure to capability and ask a bigger question. From generating images to generating stories, is multimodal generation just stitching outputs together, or is it building meaning across them? See you next time.